Right, here we go with some hints for homework sheet 2. First question, nice wee gentle one to get us started. Solve that equation. Now it's a polynomial, so that means we're going to have to use our synthetic division. So the coefficients, the 2, the -5, the -11, the 20 and the 12, they all go in our table. And then remember, what we're trying to do is we're trying to get a situation where the number in the box here at the end is 0. So our usual procedure, down, up, down, up, down, up, down, up, and then down. Remember, we add going down and we times to go up. However, difference this week compared to last week is we don't know what the starting number is. So you need to guess that. Once you've guessed that, so we get a 0 in the end, brilliant. That gives us one factor. Then we're going to repeat it again. So we're then going to just move down and do the same thing again with your new numbers that you've generated here. Again, trying to get 0. And that will give you another factor. And if you keep going, you'll then end up with 4 brackets equal to 0. And because this question is a solve one, then you're going to write your answer as x equals, x equals, x equals, and x equals. So 4 answers. They're all different. So let's see if we can do that. Question, recurrence relations. This time we're told that the limit is equal to 5,000. So we know what the limit is, which is a wee bit different to normal, because normally that's what we're finding. And we've got to work out the value of m. Okay, we're also told in the question that the value for c is 200. So let's put that in there. Okay, so what formula are we going to use? We're going to use the limit formula, which is limit is c over 1 minus m. So I'm going to put 200 in there. I'm going to put 5,000 in there. So I've got 5,000 equals 200 divided by 1 minus m. How am I going to go about solving that? Well, if I write it as 5,000 over 1 and then do some cross multiplying, so do 5,000 times 1, take away 5,000 times m equals 200, and then just solve the equation to get m equals. Question 3. Prove that the line is a tangent to the circle. So we're going to take this x plus 6 and stick it in there for y, and stick it in there for y, and then we just get one of these great big monster algebra equation things to solve. Let me write it all out for you. Okay, and once you've removed all those brackets and once you've tidied it all up, you should get to a situation where you've got 2 brackets equal to 0, and these brackets need to be the same, so that you only have one x number. Excuse me. And once you've got the one x number, then that proves it's a tangent. If you don't want to go down that route, once you've tidied all this up, the other route you could go down is your b squared minus 4ac is equal to 0. So whichever route you prefer. Most people solve it. That's the big monster question this week. Okay, first thing you have to do is to find the equation of median BM. So median BM is a line through B that cuts that side in half. Okay, median means middle, so middle of the other side. So what's the process that we're going to go through? We're going to work out the midpoint of AC, that's your M. Once you've got that, you're then going to work out the gradient of BM, okay, because you know B and you've just worked out M. And then once you've got that gradient, we're then going to use y minus b equals mx minus a to get the equation. Okay, so 3 stages: midpoint, gradient, and then the straight line formula. Same triangle obviously. This time we're asked to find the equation of the perpendicular bisector of AB. Okay, so we're trying to find the equation of this line here. So perpendicular bisector, so what we're going to find first of all, we're going to find the midpoint, because that's the bisect part of AB. Then we're going to find the gradient of AB, because that's then, excuse me, is going to lead on to the perpendicular gradient. And then we're going to use the y minus b equals mx minus a. Okay, so 4 stages this time. Find the midpoint of AB, find the gradient of AB, that will then lead you to the perpendicular gradient, and then use the midpoint, that's the important part, and the perpendicular gradient in the formula. Then for the last part of the question, we need to work out where these lines cross. So if we go back to the one that we found originally, that was this line here. So we're trying to find where these lines cross. So for the part C of the question, we just need to do simultaneous, I can't fit it in, simultaneous equations. Okay, 5, back to a shorter question. Now, this is not the question, I'm just going to do this one as an example to remind you what to do when you complete the square. So this is my example, not the one in the homework, so go back and do the one in the homework once you've looked at this. First thing we do is we take a common factor, so I'm going to take 2 out of x squared minus 6x, and then remember just the first 2 terms, so 2 goes into 2 and 2 goes into 12. Next stage, once you've done that, once you've taken the common factor, you then need to make a square bracket. How do you do that? Well, x in the front, because the x times the x would give you the x squared. Now we need to work out what would have given us 6x in the middle, and that would have been take away 3, because remember we always just half that number. Now looking at our expression, we've got negative 3 here, which we're going to have to square. Negative 3 squared is 9. Timesing that by 2 would give us 18. Okay, negative 3 squared, 9, times 2 is 18. However, we don't want 18, we want negative 1. So how do you get from 18 down to negative 1? By taking off 19. And that's me completed the square. Question 6. What's your condition for real roots? The condition for real roots is that b squared minus 4ac has to be bigger than or equal to 0. Okay, so if you look at x squared minus 4x plus k, identify what your a, your b and your c are, and once you've got these 3 things, plug them into this equation and solve it, and you should end up with something like k is either bigger or equal to, maybe less than equal to, depending on the sign, and so on. Question 7. Do these circles intersect? Okay, so best thing to do with these is for each one, work out the centre. So for the first one, the centre is 0, 0, and the radius is the square root of 25, 5. And what I'm going to do now that I've worked that out, I'm going to plot that on a wee graph. So the centre is 0, 0, radius of 5, oh that's not very good, eh? So it looks something like that. Okay, then do the same with the blue one. So work out the centre, work out the radius, draw that on the graph, and then from that you'll see if they intersect or not. And then lastly, question 8. What angle does this line make with the positive direction with the x-axis? Okay, since we did this, the formula we're going to use for this one is m equals tan theta. Okay, that's the formula we're going to use. Okay, because we're asked for the angle, we're going to turn that round and say tan theta equals m. So if I can find out what m is, then I can use my calculator to get the theta, to get the angle. So how do I get the m? I need to go back up to my original equation and rearrange it to y equals mx add c. So take your 2x plus y equals 4, rewrite it as y equals, that will give you the m, which we can plug in here, and then we can do inverse tan on our calculator of that number, and that will hopefully give us the angle. Slight wee problem with this question, and I'll let you try and find out what it is. If I was to draw this straight line, okay, it would look like that. I'm looking for this angle on the right hand side of the line. That's the angle I'm looking for. So look at the answer you get and work out how you can tell me what that angle is. Okay, right guys, that's us.